Valerie Woolard Srinivasan is a software engineer at Panoply who wants to help web developers protect and fortify their online communities by revealing common security vulnerabilities and the best digital fencing tools and practices to keep the bad guys out. Let's give her a warm round of applause.
Thank you. So as he mentioned, I'm Valerie Woolard Srinivasan. I'm a software engineer at Panoply, which is a podcast network, and I'm happy to talk podcast recommendations if you find me in the hallway later. But right now, I'm here to talk about how good fences make good communities. Basically, how you should be thinking about and using security in your code. When you're learning to code, the entire world of the internet and developing can seem really fresh and new and exciting. And in that excitement, it's sometimes easy to forget that there are still ways that you can get hurt or hurt people with your code. And in that spirit, we're going to talk a little bit about security. So as we create code and we ask people to use it, we're also asking those people to trust us. And that trust can easily be broken, and that breaking that trust has consequences. As an example, the company Living Social was shaken by a data breach in 2013. 50 million of their user accounts fell into the hands of hackers. During the course of that breach, they had to notify all of those users that their accounts were compromised and ask them to reset their passwords. A full 20% of those people that they asked to reset their passwords never came back to the service. So in the course of one data breach, they lost 10 million users. So that's how serious this issue is. And because they didn't have good security, they lost their users' trust. As a code newbie, you might feel like your toy apps are not going to have any issues. Certainly, you're probably not working with an application that has 50 million users. But since you're not a big company and not that many people even know about your app, you may think that no bad actors would even be able to find you. That's not true. People looking for vulnerabilities on the web have lots of means, including automated ways, to find vulnerabilities and problems. So you might be asking, why would someone even want to target my app? It's just something that I'm making for fun. There are lots of reasons. There could be people who are just looking for email addresses to sell. There could be bots that are just doing this in an automated fashion against any website they can find. There could be classmates that are trolling you who just learned some new tricks. There could be people looking for personal information about your specific users. You don't have to be a big company like Living Social to be hurt by a security breach. 60% of online attacks in 2014 targeted small to medium-sized businesses. And just because you're doing good, helpful community things doesn't mean hackers are going to leave you alone. Nonprofits, church sites, and ideological sites are all still very common targets of hacking. So you've got this email in your account. Another code newbie is putting together a website, trying to connect people learning how to code and share their learning experiences. You click on this link. It takes you to this page. We've all probably filled out dozens of forms like this before to sign up for websites. You'll fill in your information, not think twice about it, and hit send. But wait, where's that information going? Who gets to read it? Can you trust the person that it's going to? Is it being stored in any sort of secure way? By sending this information through this form, you're implicitly trusting the person who made this website in keeping your data safe. There are many points during this process where your information may not be safe. And if you haven't thought about the answers to these questions, or maybe it's a situation where the information that you're giving out is not something that you're particularly worried about, that's also a fair conclusion to come to in this scenario. But if you haven't thought about the answers to these questions, you or your apps could potentially be a target. Building and being part of a community is about trust. And as a web developer, you're responsible for maintaining the trust of your users by keeping their information safe and secure. Anything that you build with code and ask people to use, you can also think of as a community, because your users are your community. Inviting people to use the code that you've built is like inviting them to a dinner party at your house, let's say. Let's say you take everyone's coats and purses as they come in, and so you're then responsible for making sure those things are safe while your guests are enjoying dinner. You would probably take some reasonable precautions. You wouldn't say, like, put them out on the front sidewalk. You wouldn't leave your door wide open. Maybe you would even lock the closet they were in. As you start coding, vulnerabilities in your code might not seem as obvious as leaving your door wide open, but they can have similar consequences. Here's 3 places where things could potentially go wrong. We're back at this form. It still seems innocent enough, but what's happening when you enter this form is that the information that you fill in is being passed through the internet and saved into a database somewhere. The specifics of how this happens depend on the architecture of the web application that the form's a part of, but we can assume that the things you put in the boxes will be passed through as what's called parameters, and we'll call them params for short. So here's maybe how I would fill out this form. And the params would look something like this. Has my name, has my email address, has birth date, and has my favorite programming language. At some point, this information has to go into a database, and if people are able to send other commands to that database, it puts all that information at risk. This brings us to our first type of vulnerability, which is called a SQL injection. SQL stands for Structured Query Language and is often what is used in our code to talk to the database. A SQL injection allows users of your site, usually through a form input, to talk to your database in ways that you haven't necessarily planned for them to do. Once they're able to do this, they can modify or delete data in ways that they shouldn't be allowed to. Here's what the creator of this app is probably expecting someone to fill in this form. This works fine, and they've written some awesome code that can create a profile for you based on this information. And when you load the next page, it'll show you people who share your same favorite programming language so that you can connect with them. But what if something like this happens and someone enters some strange input in this last box? Instead of putting in their favorite language, they've written some code that will always evaluate to true. And if the code looks something like this, instead of just getting a list of users that share the same favorite language, by putting in this strange input, I can get a list of every single user of the app and then use that for whatever I want. This could be a privacy concern because it gives me much more access to your information than I should have. This is an example of how this can happen in Rails. And here's another way to do this. In this code snippet, Rails will make sure that the inputs people enter in the form are safe before actually sending them into the database, so it won't actually evaluate it as code. This is a similar example using Django, which is another popular web framework that just uses Python instead of Ruby. The basic idea here is the same. By allowing a user to talk directly to your database, you're putting the data of all the other users at risk because you're basically evaluating what the user is putting in that form as if it's code that you wrote. And you don't want to trust your users as much as you trust yourself with your code. The second example here will again clean up the user's input so they can't execute code on your database. Users expect their data to be safe with you. SQL injection makes it possible to delete or manipulate user data. And that's why you need to make sure that when you're sending things to your database, those commands are only able to do exactly what you want them to do. We're back at this form. When someone fills the form out, as we discussed before, a user profile gets created. The users probably look something like this. They have a name, an email, a birth date, a favorite language. Most of these things, as we can see come directly from that form we were just looking at. But there's this last input, which is called admin. This doesn't come from the form. It's used by the app to keep track of what users are able to see. An admin user is able to do lots of extra things like create, edit, and delete other users that normal users aren't able to do. Here's a way that a tricky user might be able to manipulate this form. They can simulate adding an extra form field called admin that they can then set to true so that when they send all of this information back to the database, they turn themselves into an admin. If the code looks like this, it'll take all of the information that's sent through the form and just make a user based on it. This way someone can create a user for themselves and give themselves admin permissions. This will make them able to do lots of things that you don't want them to be able to do. This kind of a vulnerability is called mass assignment. The way you protect against it is by specifying the exact values from the form that you want to use and send to your database. This keeps people from being able to add extra ones. And in Rails, you can do this with a tool called strong parameters. And I've included the link on the slides, which I'll tweet out at the end of the talk, that you can click on to learn more about how that works. But as you can see, basically, you're just specifying the exact fields that you want the user to be able to modify from the form. Here are this is an example of Rails code that's not vulnerable to mass assignment. And if they send any additional attributes from these, they'll just get ignored. Django can be vulnerable in similar ways, but the examples for that are a little bit more verbose, so I've just included them in this link as well. If you're developing in Django, I would definitely advise you to take a look at those examples and make sure that your code doesn't have any of those weaknesses in it. We've talked a little bit about what can happen in the code of an app that can cause security problems, but what about before the code even comes to your server? Once you've filled out this form, the information has to get from your computer back to the website owner. It's sent through the internet in a little bunch of information called a packet, which can look something like this. And just as you have to take a couple turns on different streets before you get to your given destination, a packet has to make a couple of stops before it actually gets to the place that it's intended for. Anywhere along the way, anyone can read this information as it's like traveling across potentially like the world. So if you have users send you information through forms on your app, make sure that you're protecting their data by not asking for sensitive information or by making sure that any sensitive information that they send you is protected through encryption. And that'll only allow authorized people to decrypt and read it so that someone who just gets this packet along the way, maybe like an internet service provider or someone who controls some router that is in between your computer and the destination computer, can't just get all of that information. So we've gone through 3 examples of things that can happen with just one form on just one web application. Lots of things can go wrong, and these are just a few. And when you're developing software, you always have to have an eye towards security, towards where things can go wrong. And there are tons of other places where problems with security can happen. The Open Web Application Security Project lists 66 different types of common application security attacks. And remember that your application is only as strong as its weakest link. If you use an external or open source library, any vulnerabilities in them can also put your application at risk, even though you didn't even write that code. So as you're building new things, it can feel like security is not something that matters or that you need to worry about. but failure to keep your users safe can have real consequences to their lives and to the trust of the things that you build. Now, seeing all of this, it can be really easy to get overwhelmed, but knowledge is your best weapon, and there are tons of resources to help you get informed and tons of tools that will help you protect yourself and your users. So be sure not to panic. I've put together this GitHub repository with links to a lot of the things that I've been talking about here, and just making sure that you're thinking about security is a huge step in the right direction to building secure code. Security is trust, and it's about showing that you care about your members. By writing code, you're establishing a relationship with the people who use or touch that code, and you should take that relationship very seriously. Remember that people are using your code and visiting their apps because they trust you, and making your code secure is an aspect of maintaining that trust. So security is essential in building a strong community. Thank you.
All right, that was awesome. We got a first view of what